Welcome to this Broadcom video on IWSz Server for AAI. In this video, we configure the instance we created earlier. This video shows how to configure an instance. We'll explain the various configurations like the technical AAI specs and the specs of the IWSz instance. We'll also configure the data acquisition processes, cycles, delivery directory, and so forth. We select option C on the instance we created. We have three configuration options. Configuration of the AAI server connector so that the software can deliver the data files, configuration of the IWSz subsystem so that the software can source the IWSz data, and the software itself. This is where we set runtime options like delivery cycle frequency. Option 1 leads to the connector settings. We set the network address of the connector host as well as the two dedicated data paths for file delivery. It is possible to deliver both sets of files to the same directory. However, we advise against this if you want to maintain consistency and visibility. These directories must exist physically on the connector system. We also set the user for SFTP or FTP, which was also created on the connector host during the prep phase. We have to select a delivery method, either FTP, SFTP, FTPR, or FTPS. When using SFTP, we may have to specify a specific USS configuration file that sets system-wide SSH parameters. You reference the path and name here. Finally, if you're using regular FTP, there's a password field. This password is optional and will depend on your FTP configuration. You have to provide a port if you're not using the 21 default. You can press Enter when you are done. On the next screen, we configure the IWSz subsystem we're sourcing from, so we're able to physically acquire the data. First, we set the IWSz primary datasets. We enter the dataset name of the subsystem message library that is allocated to the EQQM, LIB, DD statement. The same goes for the checkpoint dataset allocated to the EQQ, CKPT, DD statement, and the parameter library allocated to EQQ parm. We enter the parm lib library member that contains the batch OPTS statement that provides batch job options for the execution of IWSz programs. The same goes for the parm lib library member that contains the options for the execution of the EQQY, CANE, program for the generation of the current plan report. We specify the track log dataset name created with the current plan extend or replan job. It's allocated to the EQQ, TR, out, DD statement in the relevant JCL. The same goes for the job tracking archive dataset allocated to EQQ, JT, ARC. Finally, we specify the number of JT log datasets used by the IWSz subsystem. The default is 5. We press Enter to confirm. Finally, the last screen in the configuration sequence is the software itself, in other words, the runtime options. Event data is acquired every minute, but you can set acquisition to manual only so that file sends are not automated. If automated, the acquisition cycles are low since definitions are stable. The default is once a day at midnight, but you could conceivably poll twice a day if your scheduling configurations are being updated. During instance creation, we define the ZFS file system so it could be mounted at IPL. During instance configuration, we need to define the directory in that ZFS, where the data files will be delivered prior to sending to AAI. You can generate an ERTA extract for the purpose of runtime analysis. We set the configuration fields for automation time and delivery path. Extracts are limited to once a day. The report is generated in the CSV format and delivered in the indicated path on the connector host. You decide how to best use the ERTA report, graph, import in a web page, or anything else. We'll spend a bit more time on the ERTA report in the instance request module. You press Enter when you are done. This is a sample of the configuration datasets. We find the AAI instance ID, the AAI host DNS, the delivery directory path, the file transfer method, and so forth. You will see this information once the instance has been configured. Thank you. This concludes the video.